also question.
So they can hear me. Microphone as well. Okay. All right. Now we're really going. Okay. Yeah. So you can imagine there could be functionality, capability that's on some other blockchain system and not on the one you're on. So having some cross-chain system that would allow you to be doing, connecting multiple blockchains at the same time to say access an automatic market maker on one chain and use some liquidity that's on another chain and some liquidity that's on a roll-up. Let's get back here. All right, and of course there's liquidity pooling. So imagine you've got some ETH on one blockchain, say Binance Smart Chain, someone Polygon, someone Mainnet, and you want to do something that needs all of that at the same time, and you want to execute that. You need to have some cross-chain capability. Otherwise, you've got to piecemeal move something, move the value to one chain and then do something. Wouldn't it be good if you, one transaction, you could do it all? There's also capital utility. So the ability to use assets from all the blockchains in one transaction, which is pretty much what I said. So when I talk about value transfer, how does it actually work? So you've got mainnet, you've got some other blockchain, you say, all right, I want to send 4 ETH. But how does that really work? Well, you're going to have to send a transaction to request that it actually happens on the starting chain, on the source chain. But the concept of ETH doesn't exist on the other blockchain. So, you can't send 4 ETH, the native asset of Ethereum mainnet, to some other chain. So you end up using what's called wrapped ETH. So wrapped ETH is essentially just an ERC20 token. And so your overall process is this. And so you buy some ETH, you buy the wrapped ETH as a starting point. And then with ERC20 contracts, either you're the person doing stuff or you have to approve another account to do things on your behalf. And so what you do is you do an approve on that contract. And then you go and do the transfer. And so send my 4 wrapped ETH to some other account on some other blockchain. And then it's going to actually do the transfer on the source chain. So transferring from your account to a bridge account. And so essentially transferring ownership. So now on that source chain, you no longer have your 4 ETH. And then by some magic protocol, which we're going to talk about, you get that communication across. And then what you do is you do the actual transfer from the bridge contract to your account that you specified on the target blockchain. And so that's how you could do a value transfer. And of course, you could do a transfer, but you could also mint it. So maybe there is no value stored on that chain in the bridge account. And so the bridge just mints new value. And so that's another way of doing things. And so at the end of all of that, the bridge now has 4 more ETH on mainnet, and Alice has 4 wrapped ETH on that other chain. So you've shipped coins across. But there are a lot of other use cases as well. So there's supply chain financing. There's provenance, transparency, cross-border shipments, and inter-CDBCs, so central bank digital currency payments, when you've got multiple central banks with their own CDBCs and you want to transfer money between countries, essentially. And in the EEA, we've got a whole stack of use cases that we published about a year or 2 ago. So one thing that I've been working on quite a lot in recent months and year or 2 is the cross-chain protocol stack. And so there've been all these home-baked, if you will, protocols that people have just munged all of the everything together. And like, if you think about, like, say, TCP/IP and all that protocol stack that we've all learned, for those people who did computer science or even engineering, you would have had this, like physical layer, and you finally get to the application layer or presentation layer. And with blockchain, it's like we've got that, but it's all been munged into one. And so all the protocol stack is munged into one piece of software. And I'm saying, well, let's not do that. Let's have an application layer, and where you have applications and they operate across chains. And so that's separate software components, and they're designed to use the function call layer. And the function call layer executes functions across blockchains. And so you can do it can actually call a function that's on a remote blockchain and get results back. And then the messaging layer is used by the function call layer to ensure that you can trust information from a remote blockchain. And so the idea is to have these 3 separated layers of the stack. And having that gives you, with these clearly defined interfaces, gives you interoperability. So applications can use a function call layer, and the function call layer can use messaging layer, and different companies can have developed different parts of the stack. And so it means that companies can work on doing what they're good at. So at the moment, I mean, when I posted this on LinkedIn at some point, someone said, oh, thank God something like this is coming along, because we implemented that, but we weren't experts at that layer, and we just put it together and crossed our fingers. They didn't say they crossed their fingers, because I guess that would have done a bit of reputational damage on their company. But that's essentially the implication of their message was, we want to focus on what we're good at. And you could be an infrastructure provider. So we've got a lot of companies that do these cross-chain communications at the moment, but really you can think of them mainly as messaging layer companies, and where they're providing a way for you to trust information from a remote blockchain. And they have glued on top these other layers to allow you to do token transfers. But generally, it's just baked in. It's not something they're good at. And hence the technology they've used at the function call layer is very primitive. And within the EEA, we're standardizing the layers between the stack. And the idea is to launch a test network sometime in about 4 or 5 months to allow different vendors to essentially try out the interoperation of code between the stack, layers of the stack. So I'm going to talk a little bit, and I need to work out how to get my iPhone to not turn off when it's got its stopwatch on. But so there are design choices at each layer of the stack, and I'd like to talk a little bit about them. So in the messaging layer, how things work in the Ethereum space. And so when I say Ethereum, you've got to think of it as Ethereum virtual machine space. So EVM now covers a darn lot of blockchains. There are a lot of blockchains out there with different architectures, but there's an awful lot of them that have EVM capability. So even Hyperledger Fabric has the ability to run EVM code now. And you'll find that pretty much any system will want to have EVM capability. And the reason for that is that 98%, 99% of people who know anything about blockchain and writing software know how to write it for the EVM. So if you can have the EVM work on your blockchain system, then you've got all these people, all these software developers who can write code for you. So in the EVM land, you can have a function and it can call an event, and that event gets emitted. And you have this sort of system where you have events and they include the address of the contract that emitted the event, topics, so essentially the function name or the hash of the function, and data, the parameters of the actual event. And they get included in a transaction receipt, and the transaction receipt is included in the block header. So what that means is an event is linked to a certain block in a blockchain. And so when a user puts in a transaction into a contract, you're emitting an event. And so you could programmatically, based on your application, work out what event you want to emit. And it can be proven on a remote blockchain. So one thing to keep in mind, though, when you're thinking about these systems is finality. So as you can see, you've got a blockchain and then it forks. And so the top ones become stale blocks or orphaned blocks. So if you had an event emitted and related to a block that becomes orphaned, you've got a problem. So what you need to do is wait for the blocks to become final before you start trusting information that is emitted. So yeah, and that's pretty much what that says. So assuming you have these events that get emitted, you can imagine you could have a system like this, where a user talks to or submits a transaction, talks to a business logic contract, talks to a bridge contract, emits an event. And then you have some relayers that transfer across all of the block headers to a destination blockchain. And then a user can then submit a transaction on to that destination chain saying, here's the event, and here's a proof that that event was generated by a block that you now trust because the relayers have signed and say, here is the block. So, that is a way you could do it. But if you did it for all the block headers, then though it's going to be simple, you're going to be burning all this gas, transferring all these block headers all the time. So what you could do is you could choose to just send the block headers that you need to send, because they're only the ones that have got transactions that emitted an event that are needed on that remote blockchain. And another approach is, rather than having each relayer submit separately, they could collaborate. Another system that you could use is, rather than having relayers submitting transactions to remote blockchains, you could have the user submit that transaction. So what you could do is you can have the user talk to nodes that are called attesters. The attesters have observed the blockchain, seen those events getting emitted, and then they then work and sign it. And then the user talks to those attesters, then they can submit the attestation that this happened on a remote blockchain. Again, the attesters could talk to each other, make it easier, so you only have to talk to one attester. The relayers themselves could see those events and they could submit the signed event themselves. So again, a different mechanism. Or you could have more complex systems, and this is how the Solana bridge works. You could have attesters talking to each other. They could see an event and then submit the signed event back to the source chain. And then you can then take that signed event from the source chain and submit it on your destination chain. And that's good because the attesters then are submitting back to a cheap chain and letting the user bear the cost of submitting the information to the destination. Or you could have an even more complicated system like the Celo system, which is aiming for scalability, where you have what's called an incremental Merkle tree. And with an incremental Merkle tree, you can see that message 1 and 2 can be proven by root 1, but then message 1, 2, and 3 can be proven by root 2. And so what it allows you to do is just transfer some of those routes to the destination. So it increases the latency, the time between when you can do something on source and destination, but it reduces the cost. So some of these schemes also go via hub blockchains as well, which let's not worry about that. All right, what about a function call layer? So what is a function? Here I am, I've been banging on about functions forever and haven't actually defined them. So you can imagine you have some code and you go con B, so contract B dot trans, and then over there you've got trans. So it's a function has a name and it has parameters. The parameters can have different values depending on what you want to do. So for instance, the address to and from can have different values depending on which account you're sending to and from. And so on a single blockchain, it would look like that. But if you're on a multi-blockchain system, then you've got to worry about doing some sort of cross-blockchain call to do that transaction. And so that's what cross-chain function calls do. They allow you to execute those function calls across chains. And so when you're thinking about these sort of at the function call layer, you can have atomic systems or not atomic. So most of the systems that are deployed today are not atomic. So what that means is the source happens, but the destination may or may not happen. Atomic means that they'll either all go through or all of the changes be reverted. And that makes your life much simpler, because then you know that you're not going to have partial updates. You're going to have consistency across the system. You need to have linkage between the bridges. So if you've got two bridge contracts, one on each chain, they need to be linked to each other so that then the bridge on the destination only reacts to information that's coming from that source. You need to have replay protection, so you can't sort of have a transaction submitted to the destination twice and, like say, pay Peter $50, right? Let's keep on submitting that. You need to have replay protection. You need to time out as well. So if you don't want to be reacting to something that someone sent through, say, 3 years ago. And you need to be able to authenticate. So why could a transaction fail? So why are the existing systems a little bit, not good? And if you're executing code, you can imagine they might revert, but also the gas pricing might change. So you might submit something, might not have enough gas, so it might fail. It might be configured incorrectly, so the nonce might not be right. So that, again, the transaction might get rejected. It might be a permission system and your permissions might have got revoked. There's a whole range of reasons why transactions might fail. So if you look at atomic versus not atomic, you're getting atomic updates across chains. If you have failure, atomic protocols, it's handled by the protocol, where if there's a failure and it's a non-atomic approach, you've got to handle it yourself. There is a gas cost premium, I guess you could say. So if everything was executed on a single blockchain, assume that's one, and then these non-atomic function call protocols, they're about 3 times as costly, and atomic protocols appear to be around about 9 or 10 times. It does depend on what you're doing, but there is a cost. The non-atomic, you don't have to worry about locking, but then you obviously got then you can have failures. Non-atomic, it's really a non-standard programming model compared to blockchain standard programming. It's not what people are used to. Whereas with these atomic protocols such as GPAT, you've pretty much got what people are used to, except the logic is spread across blockchains. So if you've got an application developer that's used to developing on, say, Ethereum mainnet, then they can now develop across blockchains using this protocol. What about at the application layer? What are the design choices there? So again, you've really got to be looking at access control. So your function call layer has to provide this access control so that so normally in a single blockchain system, you've got this message.sender equals some authorized account. Well, how does that work in a cross-chain system? Well, you've got to have the function call layer has to be able to tell the business logic layer, look, this is who called you. So they have to have the capability and have it done in a verifiable way. So what blockchain called you and what contract called you. You need to be plausible as well. So I didn't cover this at the other layer, but you can imagine if you've got some bridge that's got a, I don't know, like the Poly network, you've got $600 million on your bridge, and suddenly you realize something bad's happening, you probably want to pause the bridge and just go, oh, let's pause. You know, we've lost $10 million so far. Let's not lose the other 590 million. Yeah, so having a pause feature both at the function call layer and at the bridge layer, you know, even if every time you do any transactions, it costs like an extra 50 cents worth of gas, the ability to stop, you know, a $600 million failure and limit it to say $10 million feels really good. Yeah. So, and if you're using a non-atomic protocol, you have to have one of these functions. And I find these functions frightening because if you've got an ERC20 bridge and the transaction on the destination could fail. So if I say I'm transferring $1,000, I transfer $1,000 on source, it gets escrowed into the bridge contract. So bridge contract now owns my money. On the destination, nothing happens. And I'm there staring at my computer going, oh, I've just lost, my transfer's failed and I've lost $1,000. You know, where's the telephone number? You know, who do I email? And so anyway, assuming that you work out who to email or contact, then the operator of the bridge has to do something. And these contracts have this sort of thing in it, where it's transfer random token to random recipient, random amount. Now, Katrina's saying she wants to be the admin who gets to control that when there's $600 million on the bridge, because then she's there and she goes, I think I'm going to go to South America and hang out there for a while. I think 600 mil could, you know, do me well. Yeah. So yeah, the idea of having some admin transfer function is I think reason enough to say, let's have an atomic protocol and not have one of these non-atomic protocols. Because if you've got an atomic protocol, you don't need this because it's either all going to go through or it's all going to be reverted. So you can have different locking designs as well. I won't go into that. And there's a whole, yeah. All right, yeah. I think there's a whole lot of detail there, but I won't bother. I think this is the really big thing though for the talk, which is having that cross-chain protocol stack with standardized layers between the stack is going to give us a new era of blockchain because you're going to have infrastructure providers that are going to say, all right, I'm going to stand up the infrastructure for the messaging layer between that and that. And if you want to use it, you know, I'm going to charge you this fee. And, you know, you'll have to pay my fee, but, you know, you can trust my messaging layer. And then other companies will come along and they'll offer function call layers. And they'll say, we've got some really cool software that operates here. And then other people say, well, look, we just don't want to know about this stuff. We just want to have the application. You know, we previously operated on a single blockchain. Now we want to operate across chains, and we just want to be application developers. We don't want to have to create all this infrastructure from scratch, you know, really. And so, yeah, so anyway, that's my talk. And how do I actually go? Oh, 24 minutes, that's not too bad.
So I can imagine the pause feature in the application here.
So the function called bridge contract is a separate contract. And you can just, you know, you would have admins who would be authorized to just pause it. Yes, the whole thing stops. So yeah, it would be a really interesting thing to think about. You know, when would that be a good situation to do?
Transactions is already like complete.
Yeah, it depends on the design. But yeah, and at the moment, you know, so at Consensus, we're developing this open source and Apache 2 licensed as well. So, you know, you can have a look at the code. You can do pull requests on the code and say, that's a bad idea. You should do, you know, the pauses should allow the in-flight transactions to end, whatever. Yeah, it's a good question as to the actual design. And the good thing is, though, as well, it's modular. So if you don't like my function call approach, you can create your own function call approach that has applications. And because it's defined interfaces, the application should work with your component at that level, and your component should work. So you should be able to modify. So I think it should allow a new era of innovation as well, because, you know, like you could imagine that Muthu is there and he has a undergrad, master's, PhD student, and they want to do something, but they don't want to have to create a whole stack. They can just create this component. You know, they could just work on a new function call layer that has a better locking mechanism, because us people at Consensus don't know what we're doing with locking mechanisms. And here's a better locking mechanism. And it's entirely possible. You know, you could just focus on the bit that you want to focus on. Anyway, there was another question. Go.
So my question is on the infrastructure. I'm assuming that most of these is running within the smart contract, but if you consider the Ethereum virtual machine, it supports certain functionalities and it has its own definition of integer flow. And when we're talking about interoperability or cross-chain in this context, you may not be having the same set of functionalities. So from the practical point of view, what kind of challenges you're running into? That's my first question. The second question is, don't you think off-chain solutions are much better for interoperability or cross-chain, because at least you have more room to play with there in terms of gas cost and the complications, and you don't have to deal with the restrictions of the virtual machine itself.
Sure. Okay. So addressing the first one is, you know, different compute platforms, so different blockchains have different capabilities, and how do you handle that? It's a matter of having an interface and saying, all right, well, this is what parameters we're going to take, and then it's really up to calling the function on that chain and it doing whatever it does. So not trying to dictate exactly, you know, we're not saying, all right, here's a function executes like this in EVM, and then it executes like this in Quarter. That's not what we're saying. We're saying, well, here's your function in Quarter. We're going to execute it. It's going to give a result back. And so, yeah. And the other one was, are we sure we need to do this on chain to do the, yeah. So I think you do. So, I mean, if you've bought into this whole decentralized thing, and so you're thinking, well, it's good to have automated contracts, you know, automated logic and whatever, you know, so blockchain smart contracts, then having the ability to have multiple chains that are interlinked and you can see that it's all happening on chain. And even though it's cross-chain, it's still, you can see. I think if people have greater faith that that's, you know, a real system, because people get worried that, you know, if you do something over here and then do something over there, how is it linked, you know? And why are we using blockchain at all? You know? So I think that's it. All right. Oh, yeah, sure.
So you mentioned the relayers and investors for messaging. Can you tell us more about who these are and what trust assumptions are on them?
Sure. And I think it's going to depend on who they are. So, so Chainlink, they run a set of oracles, and I think you could think of their oracles as being messaging systems. So that's one example. The MakerDAO, so they have a set of oracles which are used to set the price of the DAO. And so they're saying they're going to use their oracles for cross-chain, and they're really going to be at the messaging layer. OneChain, they have a system of slashing, and, you know, like essentially they have about 500 nodes where people, you can stand up a node and you stake $50,000 US minimum to be a node. And they do 17 of 25 signing. And if it's proven that you've signed something fraudulently, then everyone who signed gets slashed. So, you know, that's a fair bit of money getting slashed. And they also limit the amount of value on their bridges. So they have time limiting and overall cash limiting. So their bridges only last for a month and then everything gets settled. And so you're limited by the amount being staked for how much can be on the bridge. So you can have multiple parallel bridges between the same set of chains. So that set of assumptions is if they behave badly, they get slashed. But other chains, sometimes you'll see that it can be based on who the validators are for a chain. So say if you're in Solana land, maybe there are a set of trusted validators that run that Solana blockchain. So they can be the validators. But in other situations, you might have other entities that you deem to be good signers. But obviously the fewer signers, if you only got one signer, then you're really trusting that one signer to do the right thing. So again, it does come down to who do you trust. The best, obviously, mechanism is something which is related to the actual consensus algorithm of the source blockchain. But that's not always possible. It's going to be interesting once we get to Ethereum 2, you can imagine we've got proof of stake. And so if you could have the nodes that are doing the proof of stake signing to also do this signing, it'd be fabulous, but I don't think they're going to be interested. So you're going to have a separate set of attesters doing that signing. All right, I think I must be out of time by now. Yeah, and so, all right, do you want to try and